Have you ever heard of the phenomenon that Albert Einstein referred to as spooky action at a distance? This phrase describes quantum entanglement is considered one of the most mysterious and perhaps one of the most difficult concepts to understand in physics. But don't worry. Today, we will explore exactly what this seemingly complex quantum entanglement is and why it feels so strange. And ultimately, I will explain in the simplest and clearest way how it can impact our lives. Let's explore this amazing phenomenon that shakes the very foundation of the world we live in. The first step to understanding quantum entanglement is to know the little friends of the quantum world. These are very small particles like electrons and photons. The particles in this microscopic world behave fundamentally differently from the objects we experience in the macroscopic world. For example, photons, known as particles of light, and electrons that constantly orbit around atoms, sometimes exist as waves, spreading out widely, and at other moments, they can be observed in the form of discrete particles, referred to as wave-particle duality, which is one of the most fundamental concepts of quantum mechanics. This duality is a phenomenon that is hard to imagine in classical physics and illustrates the non-intuitive nature of the quantum world well. These tiny particles, which behave in such an unpredictable and peculiar manner, are the main characters of the phenomenon of quantum entanglement. They influence each other's existence and are connected in ways beyond our imagination. Now, shall we approach the core concept of quantum entanglement? It's easier to understand if you imagine entangled particles as magical pairs that are specially created to be one team. I have a special device called an entanglement generator. This device has the ability to always generate a pair of particles that have a specific relationship with each other. For example, quantum particles have a unique property called spin. This spin is similar to the concept of a small top spinning clockwise referred to as upspin, or spinning counterclockwise referred to as downspin. This characteristic represents the intrinsic angular momentum of quantum particles. They can only have two states, either spin up or spin down. The moment you press this magical generator button, a pair of electrons, which always have opposite spins, is born simultaneously. The most important point here is that from the very moment these two electrons are created, they share the promise that one will have spin up and the other will have spin down forever. However, we cannot know exactly what spin state each electron has until we actually observe or verify them. It's as if they exist in a state where the two spin states, namely upspin and downspin, are simultaneously superimposed. This superposition state is another key concept in quantum mechanics, meaning that particles can exist in multiple states at the same time. The fact that two particles share each other's fate and are bound together in a single state is the starting point of quantum entanglement. And it exists in a state of uncertainty that cannot be known until measurement. Now it's time to feel the strangeness of entanglement more vividly. I carefully place the magical partner particles I created into separate boxes. And one of them is sent to me here in Seoul right now, while the other is sent to you far away in New York. Until I open this box, I cannot know the spin state of both particles, whether they are heads or tails, that is, whether they are in a spin-up or spin-down state. It's like tossing a coin and being in a state where it hasn't been checked yet. Each particle exists in a probabilistic superposition state until it collapses into a specific spin state. Now, let's assume that I opened my coin box in New York and it showed heads. Surprisingly, at that moment, if you open your coin box in Seoul, it will definitely show tails. Conversely, if I checked the back side, you would inevitably check the front side. This phenomenon occurs with such precision, as if it were a pre-written script. What is even more surprising is that the moment I check the state of my coin, it means that even if these two particles are far apart, even at the edge of the universe, where it takes millions of years for light to reach, the state of the other coin is determined simultaneously and instantaneously. This phenomenon demonstrates the characteristic known as non-locality, which even surprised Einstein. It's as if there is an invisible telepathy connecting the two particles. This is the most mysterious and peculiar property of quantum entanglement. By measuring the state of one particle, we can instantly know the state of the other particle that is physically separated. This has caused a lot of controversy because it seems like information is being transmitted faster than light. Because of this phenomenon, Albert Einstein referred to entanglement as spooky action at a distance. Einstein claimed in his theory of relativity that information cannot be transmitted faster than light. However, because the phenomenon of entanglement seemed to suggest that information was being transmitted faster than light, he could not hide his astonishment at this phenomenon. He believed that this phenomenon was difficult to explain with existing laws of physics, and sought to use it as an important basis for pointing out the incompleteness of quantum mechanics. However, the existence of entanglement has been strongly demonstrated through Bell's theorem and actual experiments. But you must not misunderstand here. Quantum entanglement simply shows the correlation of states. In reality, it is not possible to actively transmit information as if we can send and receive messages faster than light. We cannot obtain any information until we measure the state of the entangled particles. And at the moment of measurement, that information is only confirmed. In other words, it is impossible to communicate by instantly transmitting information through entanglement. This is the most striking example that shows completely different rules and logic from classical physics that we are familiar with. This suggests that the fundamental workings of the universe are much more complex and counterintuitive than we had imagined. And it demonstrates that the universe can operate in ways that differ from the causal relationships we intuitively understand. Such strange and mysterious phenomena of quantum entanglement are rapidly emerging as a key driving force for future technologies, going beyond mere curiosity. Its power is revealing itself beyond imagination in quantum computers. The basic unit of information in the general computers we currently use, the bit, has a value of either 0 or 1. This is similar to independent rooms that are strictly separated by partitions. For example, if there are 2 bits,
it can represent a total of 4 possible states like 0, 0, 0, 1, 10, 0, and 1, 1.
A conventional computer opens these 4 rooms one by one in order to perform calculations. In other words, it can only process one state at a time. However, the basic unit of information in a quantum computer, the qubit, is different. Thanks to quantum entanglement and the quantum mechanical property of superposition are simultaneously present in one large room without partitions. For example, if there are 2 qubits, instead of the 4 states 00, 01, 10, and 11, being separated into individual partition rooms, these 4 states act as if they are all simultaneously superimposed and coexisting in one large room. A quantum computer can observe all 4 states at once and perform calculations simultaneously. Quantum computers can manipulate these superposed states all at once, making it possible to perform complex calculations. Imagine this. What if 8 qubits are perfectly entangled? It would be like having 256 possible states existing simultaneously in one space without any partitions. While a classical computer has to check each of the 256 rooms one by one in order, a quantum computer can process all 256 states at the same time and compute in parallel. This is quantum parallelism, and it is the fundamental reason why quantum computers can solve certain types of complex problems much faster than any existing supercomputer. This technology could be the key to solving long-standing challenges in areas such as drug development, new material design, cryptography, financial modeling, and artificial intelligence learning. It goes beyond simply increasing computational speed. It enables problem-solving in a new paradigm. Quantum entanglement gives us profound insights that our universe may be connected much more deeply and fundamentally than we think. The idea that particles, which are considered to exist individually and independently, are actually connected by invisible strings and can instantaneously affect each other. Questions about whether the complex world we live in is also interconnected in unseen ways. This phenomenon resonates with the concept of connectedness in ancient Eastern philosophy, allowing for intriguing discussions that traverse the boundaries between science and philosophy. Quantum entanglement is still filled with many mysteries, but at the same time, it will open a new era of technology that humanity could not even imagine, fundamentally expanding our understanding of the universe and reality. Through this strange and beautiful phenomenon, we may be learning another language of the universe. Quantum entanglement will broaden our horizons at the forefront of future science and technology, becoming one of the most powerful inspirations that stimulate our imagination. All of this content was created with the help of the AI collaboration tool, Gemini. I'll be back next time with even more interesting stories about quantum mechanics. Goodbye, and subscribing to the channel always gives us great support.